coming, everyone. So I first thought I could call the talk doing boring things with F#, but then I figured nobody would come to my talk, so I put on this like fancy sounding title, but it's really going to be about doing boring things with F#. So who wants to leave now? Feel free to leave. It's going to be about boring things, but actually, if you're a software developer, then you know that unfortunately boring things are an important part of what we kind of have to do when we're doing software development properly. And so what I really want to talk about is doing all the other things that you have to do when you do programming, software development, and all the other things that you have to do when you're not actually implementing your core interesting functionality. And there's a lot of things you have to do. I think most of the time you're actually doing other things than writing your core interesting part of your system. So F# has been sort of open source for a really long time, and this is something that's been progressing further and further. There's just a tweet from, I think, yesterday or the day before announcing that the Visual F# IDE tools, it's now part of the open source release. So F# has been open source since the beginning, or well, not quite, but for a really long time. And there's been Apache release, Apache licensed version of F# on GitHub. And that's being used by people like Mono, who are integrating F# into Mono. The next step was that Microsoft actually started accepting contributions. So community can now contribute to F#, and the changes, if they're sort of reviewed and accepted, will make it into the next Visual Studio release of F#. And this is about actually releasing the Visual Studio integration or accepting contributions to the Visual Studio integration. So the F# community has been pretty amazing about doing tools for F#. There's the Visual Studio F# Power Tools project, and pretty much all of that can now be sort of merged into Visual Studio. So there's really a lot of open source happening around F#, and this is just the core F# code base. But if you're interested in F# open source stuff, there's the github.com/F# repository, and that has some of the core libraries around F#. I'll be probably mostly using things from there in the talk. There's also FS projects on GitHub, which is a repo with various sort of work in progress, interesting incubation projects that people in the community have been working on, like interesting type providers for accessing some fancy data, or I think the SQL type provider that Ross has been talking about last time is there as well. And there's also this repo on Codeplex. If you haven't seen Codeplex before, it's like GitHub, but from Microsoft. But that's where the F# sort of compiler and the IDE tools are. So there's a lot happening around F# and open source. And open source is a lot of fun, but when I created my first F# open source project, nobody was using it, and it was really good because you know, I was author of an open source project, but nobody told me like how to change it, and nobody complained. But then people started complaining about bugs, so I had to do some testing. People started actually contributing, which is really great, but then I had to actually build a new version, release the new version, and that's kind of a lot of work, because you have to get the changes, run the test, see if it still works, build the new libraries, new DLLs, create a NuGet package, upload it somewhere, and then people actually want to have some documentation as well, so you have to write documentation. When you change something, you have to update the documentation, publish it. So really, if someone sort of sends you just one little change, you don't want to do everything by hand, because then it will take you like an hour just to update the project when someone contributes. And that's really a major sort of blocking issue if you don't really have too much time. And I'm using open source here as an analogy, but really this is the same kind of problem you have in your own company when you're building your software. So all of the same problems really apply pretty much anywhere. And so in the F# community, there's quite a lot of interesting projects that make all of these pain points actually quite fun and make it more pleasant to do testing and building and releasing and documenting your code. So that's what I'm going to be talking about. Another interesting thing here is that when you use F# for all these boring tasks, it's actually a really good way to get F# into your ecosystem, because if you're writing tests or build scripts in F#, then really nobody's going to care too much, because tests are not part of production code. They're really important, and in a lot of sort of systems, you have even more tests than your actual code. And if you can write clever tests, then you get a lot of value there. But it's not a thing where you would sort of risk anything by using F#. So it's really easy to use F# for this kind of thing if you want to get it into your ecosystem. There's a lot of people who actually do this, who use F# for like build scripts or the documentation tools, including GitHub. They have one open source project for, I think, accessing the GitHub APIs, and they have a build script written in F# using the library I'll be using. And if you go to the websites of the projects, especially Fake, which is the build script tool, they have quite an interesting list of users. So I think what I'm going to show today is actually sort of one thing you can do if you want to start using F#. So what is out there? For testing, in F# you would pretty much use the normal .NET testing tools like NUnit or XUnit or the Microsoft Enterprise Testing Framework, Visual Studio 2011 or something. Just sort of all the standard testing tools work with F# quite nicely, and there's a few libraries, FsUnit and FsCheck, and some others that make it actually even easier to write tests. So we'll start with that. There's Fake, following the good tradition in the F# community of prefixing names of things with F. Here it actually worked kind of well. So Fake is the F# makefiles system. You can write build scripts that do things like run. You don't really have to write the compilation step in Fake. You would normally just call MS-build to build your project. But then it lets you do things like build a NuGet package, publish it, copy something to a deployment, and so on. F# formatting is a tool for doing documentation, and I'll show that later on. And finally, there's F# project Scaffold, which is like an open source project template that you can use if you want to create an open source project on GitHub. So the first three, that's really relevant if you're doing something internally. You can use the first three pretty much for any project. The scaffold thing, that's more useful if you're doing open source, but you can have a look at it and there's a lot of ideas you can just copy from there. Another point really here is that pretty much all of these, in some way, you can use it with C# projects as well. So if you're building C# libraries or C# applications, you can still test it with F#, or build it with F# or document it with F#. So let me just show you a little example that I'll be working with. So the code you'll see in the talk is going to be really boring, but all the other things around are what matters. So I've got, let me make this bigger. I've got a single library project here. What you get when you create a new F# library, and in the library, I have this silly email validator. So it's defining an interface by requirement that represents some sort of requirement on a password, and the interface has just a single method called isSatisfied, and I can call it to test whether that string satisfies the requirement or not. And then I've got module with 3 basic requirements. So length requirement implements the interface, and it checks whether password length is greater than or equals to 8. This one checks whether there exists a digit in the password, and this one tests whether there exists an uppercase character in the password. So the type I requirement is an interface. These things in the requirements module are just concrete values. I'm using the object expression here to implement the interface rather than defining a class. But I do have one more class at the end, power validator, and this takes a sequence of requirements and it checks whether the password satisfies all of the requirements. So really just a basic library that I'll be working with. And when you create a new F# library project, it creates a library file and a script file. And in the script file, you'll have something like this. So now I can load the library in my F# interactive, and you can see that there it actually sort of evaluated all the library code, but I didn't even actually have to compile the library to do this. So if I want to play with this, I can just sort of in F# interactive do some tests. Say I can create look at my requirements, take the length requirement, and check if hello is long enough. It's not. Hello world. That's long enough. So what I'm doing here is that I'm sort of testing the project even before I actually created my project for unit tests and so on. I guess if you come from sort of strictly TDD world, then you would say, oh, you have to write the tests first. And F# doesn't really usually follow that. The types kind of give you sort of first level of tests where if it has the right type, you actually know something about it. And I find it really useful to combine this interactive testing with the proper unit testing. So when I'm doing some library, I usually start by implementing what I think is right, and then maybe I can create a couple of tests here, or tests, just sort of yeah, interactive exploration, really. So I create another requirement, like the uppercase requirement, and test whether some of these work. So this will return false for both of them, as expected. But this one will be fine. And if I create the power requirement, that's the one that composes multiple, power validator composes multiple things, then I should be able to say req.isValid, and then hello, it will not be valid because it's too short. But if I do something like this, then I'm fine. So this is sort of the setup you have at the beginning. And I think that the fact that you can run and test your code even before you compile it when you're writing it is really important thing. And it means you'll usually have reasonably correct version of your code at the beginning. So far, I really just use F# Interactive. You can actually use F# Interactive with C# libraries. Rather than doing the hash load, I could use #r, reference some library, and then explore what the library does from interactive mode. The next step is to turn this into proper tests. So if you're using C# to do your implementation, it makes really good sense to write the tests in F#, because if you use different language to write your tests, you're actually probably going to avoid making the exact same mistakes as you have in your implementation. F# also makes it nice to do things like compare collections or compare records and more complicated structures, because it supports structural equality. If you're testing functional code, then testing is really nice, because really pure functions, the result only depends on the input, so you don't need to do any complicated mocking. But you can test .NET code, C# code, and do mocking. That's also supported there. So I'm just going to show you the two interesting libraries here. One is FsUnit. So rather than writing my tests using assert.r equal or something, FsUnit lets you say 2 plus 2 should equal 4, or ships should end with PS, makes the tests more readable. And you can find it on GitHub or on NuGet. And let's actually see how we can use it. So I'm going to start just by doing this from F# Interactive, because you don't really have to. Well, I'm going to obviously create a unit test project later, but I want to start with the simplest possible thing. So if I install the FsUnit package from NuGet, that hopefully, assuming NuGet works, will install NUnit as well. There's FsUnit for other tools like XUnit. And here I can still stay in my script file and just let me copy the references from here. So I'm going to reference the NUnit framework, and I'm going to reference the FsUnit library. So now I'm still actually in my script file. Open FsUnit and NUnit framework. And the reason why I'm doing this in a script file is that I just want to start with something simple, and I can take all the code I wrote during the exploration and turn it into unit tests. So really, previously I was just running it in FsCheck Interactive. What I can do now is that I can say this, and you could use the NUnit asserts, or I can just use FSUnit and say this should equal false. This should equal true. And then I can also run these things in FsCheck Interactive. So if I had wrong test or the property didn't hold, this will sort of throw an exception, and you can go through the tests in your FSI. So this should be false. I think I'm probably going to delete some of these. They're stupid. But just an example, this should be true. So now I'm slowly turning my exploration, as my project sort of becomes more stable, it makes sense to take this from a script file and evolve it one step further. And if I want to turn this into actual tests, then I can just use the test attribute here. Yes, test attribute. In C#, I would probably call this checking length of hello should be false. So I have to come up with some ugly encoding, or maybe I could put underscore in there. So FsCheck has this tiny feature that's really sort of no rocket science, but you can do backtick and say checking length requirement of hello should return false, and I enclose it with the double backtick, and it actually compiles as a .NET method that has this name with the spaces included. That means you can't really call it from C#, but it's not really a problem when you're doing unit tests, because the NUnit test runner will pick up the name, and it will show you the nice full name in the test results. So we'll do that later on. Let me name the other one as well. So checking length of world. I'm not going to try and make the names nice and reasonable, because I can't really talk and type at the same time. And I also encapsulated all these things, all the initialization in the individual unit tests, to avoid any sort of collisions. So power validator works on sample input. And now I just started with interactive exploration, and now I'm slowly turning things into proper unit tests. I haven't yet put it into a library, so the only way I can run it is really select it and run it here. But initially, that's all right. I'm happy with that. And this is probably something I would be doing sort of before I actually release the first version of the library. Then I want to have this as a proper unit test that I can run. But before doing that, let me add one more tool here, and that's FsCheck. So FsCheck, how many people have heard of FsCheck before? Just a few. Or Quick Check. Any Haskellers in the room? Nice. FsCheck is a library, or yeah, it's really a library that you can use to write tests, where FsCheck you basically specify some property, and FsCheck tries to find random inputs that test what kind of things could possibly go wrong. So this is the usual example that everyone will give you when talking about these things. If I have a list, any list, and I reverse the list, and then reverse it again, then I get the original list. If that's not true for any list, so if that's not true for all the possible lists, then I'm definitely doing something wrong there. Reversing this twice should give me the original one. I shouldn't drop elements or something. So I could add FsCheck to the project, and I'm gonna have to use NuGet again. FsCheck. I'm lucky here because usually when I try to use the search button in this dialog, it installs jQuery. I don't know why. So now we've got FsCheck available. And I'll just reference FsCheck here. And FsCheck, so open FsCheck. I'm still running everything from F# Interactive because I'm really just sort of exploring things. I guess at this point I would already have it or I would put it in a library, but for the purpose of the talk, I wanted to go through all the testing frameworks before setting up the library. So I can say check.quick throw on failure, and what this does is that it checks some property and throws an exception if it fails. And here you have to give it a function that basically represents the property. So if I just say nothing here, and I run it, yeah, it says, okay, passed 100 tests because I'm not checking anything. I could say, create a requirement here, like length requirement. And then if I say, is satisfied on S should equal true, then basically what I'm saying, it's a wrong property because I'm saying every password should be valid. And if I run it, then indeed it finds a counterexample and gives it to me here. This doesn't work for empty string. So it can find input that's not a valid password. If I try false, then again, it finds some input, which would be a valid password. So it really tries to do a couple of clever things here. For this requirement, I can really just say, I can have a test that basically validates the exact behavior of this. So this should be satisfied if so what I'm expected is that s.length, if it's greater than or equal 0, then yeah. So I'm saying I'm expecting that this is the is satisfied returns true when s.length is greater than or equal 0. And this is really simple test that pretty much just duplicates the implementation. Who thinks this will work? Who thinks this won't work? Work. Anybody else for work? Who thinks it will not work? Who thinks it will not work because I'm asking? Who thinks it will not work for other reasons? Let's see. We'll have to try them. Okay. It failed. Because if I get string that's null, then s.length will fail. So really, the property I'm specifying here is kind of wrong, because if I get null, then the property is invalid. And what I could do here is just to say, well, really, this checking should only be done for non-null values. And now it works fine. FsCheck has this operator that you can use here. The implication, pretty much, which says, if the thing on the left-hand side holds, then check this property. And I had to wrap this in the lazy keyword to delay the evaluation. Otherwise, it would run it as part of, like when evaluating the arguments of the operator. So this is maybe a bit more sort of mathematical way of writing it, but really it just means for now I'm not checking the property. And I'm not I don't know what the library should do when I get null. I should probably say false. But I think that the implementation I have will probably fail. So what we can see here is that just by using FsCheck, I already discovered one tricky case that I should handle more properly. So that's really nice. The other thing we can do here, so for example, let's look at some other requirement. No, I'll add one other FsCheck test later. But the things we could check here, so I'll just call this length requirement matches definition. And here I have another test. What kind of things can you check with the FsCheck project? In general, this is really useful if you have sort of two implementations of the same behavior. Very often when you're writing something, you can write really simple prototype that will work for most cases, or will work, but will be slow. Or if you have a C# implementation of something, an F# implementation of something, you can use FsCheck to test that they match for all possible randomly generated inputs. That's one really good use case here. So if you can create a naive implementation and check it with the real one, the naive implementation can usually be simple, but it's just not going to be fast or something. That's one interesting case. You can also check mathematical properties. So if you have some operation, for example, like list concatenation, or even if you're calculating things like standard deviation, then you can say, if I'm calculating standard deviation, then I could say, if I rearrange the elements of the data set in some way, like reverse it or just randomly shuffle them, it's not going to change the standard deviation. That's the kind of property you can test. Or if you have some operations like list concatenation, you can say that concatenating list A with B concatenated with C is the same as concatenating A and B and then adding C. So there's a couple of sort of usual mathematical properties. If I have operation that's symmetric, what would be a good example here? Any thoughts? I don't really have a good example. You could test that plus, like 1 plus 2 is 2 plus 1. That's something you probably wouldn't want to test for integers, but if you were implementing your own numerical types or something like that, that's something you want to hold. Or you could test that getting a length of a list that I get by concatenating A and B is the same as B and A. Yeah?
How about, testing parallelization, for example? Saying a serial implementation of something equals the same thing as a parallel.
Yeah, so this is really good suggestion. We could use this to test things like parallelization. If I have parallelized version, that's maybe sort of, I don't really trust that I did parallelization correctly, I can compare that it works the same as my previous sequential version. So yeah, that's another really good use case for this. So that's sort of just another really useful tool that's available to you in the FsCheck land. Now, what I want to do next is that I want to go from this sort of simple library where I have all my tests in a script file and go to something that's more solid. And here I'm actually, because I'm talking about this in the open source context, I'm going to use the FsCheck project scaffold. You could really just add another library to your project and move the unit tests there. I'm going to download this thing. The link doesn't work. So this is a template on GitHub that was actually created here in New York, I think in November or October last year, when we had sort of, we organized a little meetup or FsCheck meetup on one weekend and met and worked on this, put it together, and I could clone this and sort of start from there. I don't really want to have my library as a clone from this because it's going to be something completely different. So I'm just going to download it and extract it somewhere, like scaffold. And what this gives you, it gives you like predefined common structure for FsCheck open source projects. And it comes from the internet, so I have to click this button. All right. And we are going to go through most of the things here, but really it's pretty simple structure, and you can find detailed explanation on the GitHub page if you want to create some open source project, contribute to the FsCheck world. That's actually a pretty good explanation for everything. So it created a solution with a couple of folders, and here's my library. This is really just the simple library I had before. It created a separate test project which has a sample test, and aside from these two things at the end, it created this project folder where I've got a build script, and we'll look at that later. There's also a README document, and there's a release notes document. So these are sort of all the recommended things that you would usually want to have for an open source project. And there's also .NuGet. This is just sort of support for the NuGet package management. So nothing interesting here. But the docs has a couple of files with documentation. I'm actually going to go back here and open a project. I think this is the one I want. I'm going to open a project which is just like the scaffold I just downloaded, but I renamed all the projects to the name of my open source library, which is stuff.emailvalidator. So I have stuff.emailvalidator with my library, and I need to put in the implementation here. I'll copy that over, and then I have some tests, and in my tests, I just have, so this is not implemented yet, it's just testing that unicorn 1 is unicorn 1. I should be able to build everything, and really the idea is most of the time you can just build things in Visual Studio if you're using Visual Studio. And this builds, I have the test-driven.net installed here, so I can run the tests in NUnit, and worked. And yeah, here you can see how the methods with spaces are nicely shown in the test runner. So what I want to do next, I want to copy over the things I created here. So I'll just copy over the implementation, and I can copy over the tests. And previously I had them just in a script file. Now I'll put them in the library. And I think I definitely need to rebuild this before it will work, because the project doesn't see the other one. I think looks like it compiled. I already had the references there. And let me just, this might fail. I'll try to run the test. If it fails, it's because I have different versions of, yeah. The FsCheck one failed. That's just because I'm referencing F# core 4.3.0, and I need to reference version 4.3.1. This is probably the only difficult thing about F#. Referencing the right version. No, still wrong. I have it fixed in the next version, so I'll just skip this. In general, if you're referencing F# core, you have to make sure that all your dependencies will load the same version. If one loads version 4.3.0, another one loads 4.3.1, then they won't be able to call each other and things go bad. That's just what's happening here. But otherwise, I have a nice setup here with pretty much everything I need. So what do I want to do next? We created the library using the template, and let's look at what the template gives me here. So the first thing that's used in the template is the F# make fake, and that's in the library, in the template, that's used for, I haven't used it yet because I was just building it in Visual Studio, but I can build it from a command line, and then it can also run the tests and do a deployment and release a NuGet package for me. So let me just, this is the old version, so I'm going to close this, and I'll just comment out the FsCheck test because I'll fix it later. And now if I go to my project, so this is in part 3, right? This is where I want to be. I'll move it somewhere here so that you can see it. There's build.command and build.sh. So the whole setup is cross-platform as well. You can run it on Unix, it will work. Here, if I just run build, what it does is that it actually downloads the fake binaries from NuGet first, and then it will use the build script in my build.fsx. So let's see what it does. It prints all sorts of things. Okay. So what happened? It said there's a couple of tasks in the build script, targets. It said I'm going to clean, then restore NuGet packages. If you get the project, if you just download it from GitHub, it doesn't have all the binaries that you're referencing. So restore packages will download all the reference packages. Then, this is nice. So it also generates assembly info. Yes, I think I'm missing the assembly info here. I should put it in there. But there's assembly info here that's generated by the build script. And it put version 1.1 here. That's because this is actually, it gets this all from the release notes file. So if I do some more work on this and create another demo, which is version 1.2, and run this build script again, it's going to update the assembly info based on, yes, it has changed, based on my release notes. So it's doing all sorts of nice things. I think after doing the assembly info, it built the project and run tests. So you can see the test output here. This is what you get when you run it from the command line.
And that's just the template as it comes out of the box.
Yes, let me show this. So this is sort of the default setting in the template, and the building all happens in this build.fsx. And that's fake build script where the template just uses one particular sample. But if you're writing some builds, then this is where you can do all sorts of work to build things differently, add your own custom tasks, really depending on what you need to get done. You can obviously also test this from FsCheck Interactive. That's really nice. So if you're writing a build script, you don't have to sort of tweak one thing and then run the build script, wait for 5 minutes and see if it worked. You can really just load this in FsCheck Interactive and watch what happens as you run it. So the build script that's in the template starts by setting a couple of sort of variables. This is the name of my project. This is the summary of my project. I can put in longer description, authors, and tags. And all this is used for building the NuGet package. I also have to say, what's my solution file name? What are the locations of the test assemblies? And I also need to give it my GitHub location for the project. This is really just in the template, which assumes that you're using GitHub. If you're writing your own build scripts, you can use this as an inspiration and delete the stuff you don't need. Or Fake has a nice documentation as well. So you can just go there. And this is sort of, if you want to use the template, you only have to change that part. The actual work is done here. So I set the current directory to where I am at the moment. And this is using the helper that reads the release notes. And you can see here, my latest release has this NuGet version, and this is the parsed nodes. And then when you're using Fake, you'll be writing these targets. And that's sort of the individual steps of the build script. So I have target for assembly info, target for restore packages, target for clean, and a couple of others. And then at the end, I specify the the build order. What should happen before what? So in assembly info, I'm using a predefined thing in fake called create FsCheck assembly info, and this takes basically a sequence of parameters that it should put in the assembly info file. If you look at fake dot, you can see what all things it lets you do. So this is quite an impressive list. There's tools for integration with various continuous integration servers. Don't know what boot does. Bootstrapping fake scripts, okay. Azure helper, what can you do with Azure? You can do various things with Azure. Oh. I really don't know like half of the things that, I don't really know like 80% of the things that fake can do. But it has a nice documentation and you can find it all there. It has integration with Dynamics nav. Lots of file system utils. It's really easy to copy things between directories. I don't know what fix now is. Sounds like some hipster thing. It has really nice tools for Git, so I'll be actually using that later. If as part of your build you want to push some update to Git, you can do that. I used this just the other day when we do a release, we want to create a tag in the Git repo. You can just write it as part of your build script, and then you don't forget to do it. Yeah, there's tools for running NUnit, XUnit, pretty much everything you can think of. Oh, building zip files. So I'm building the assembly info. These two are easy, or these three are easy. Restore packages just calls a predefined thing. Clean deletes everything that's in my bin and temp folder. Clean docs. I haven't talked about documentation. We'll see that next. The build command, this just says, the bang says, give me a sequence of all the files that match this pattern. If I turn this into an array, there's really just one full path. So I get the solution, and then MS-build release is a predefined task that just builds the solution using MS-build. So it doesn't really make sense to replace that MS-build part with my own fake thing. That already works pretty well.
So is this suggested way to build multi-platform and to have multiple solutions?
So the question is this suggested way to build on multiple platforms? This works on Mono as well. It will use xbuild, which is the...
No, I mean like if I want to build 4 multiple platforms.
Oh, if I want, yes, so actually if I wanted to build for multiple different platforms, like Silverlight and .NET 4, mobile, and so on, yeah, I don't really think there's any suggested way for doing that. Like in FsCheck data, we use this and we just have multiple SLN files, one for each platform. That's a little painful. You could probably do something more clever, like parameterize the build in some way. The solution with multiple SLN files works kind of okay, but I'm not entirely happy with that. So if someone comes up with a better way of doing that, that would be nice. Yes?
So if you have different app config files for your debug and your production release, is this a place where you could take care of mapping or copying the right one?
Definitely, yeah. So the question is, if I have multiple like app config files for different builds, then I could probably create another target that just that I include in the build script and then do some copy. So I can create target, copy config, and here this takes a function representing what I actually want to do. And here I can use one of the copy helpers, say copy file, which takes the target and the source. And I can do whatever copying I need to do. So if I just finish this, there's run tests, finds all the test assemblies and runs NUnit on them. I can also build a NuGet package. So NuGet is another predefined operation which takes this record with all the specifications for your NuGet package, where I want to put it, what are my tags, description, summary, and so on. And there's a bit on documentation, so I'll explain that in a second. And this is at the end specifying the dependencies. So what I'm saying here is that clean, I have to do, well, if I want to do all, I have to run tests first. To do run tests, I have to build. To build, I need to generate assembly info, and before that, I need to restore packages. All is my default target here at the end. So if I just say build, enter, it runs these steps. If I say build release or build NuGet, then it will also do these additional steps.
Sorry,
Yes?
can you go into a little more detail on the, like, I think the NuGet one took like a parameter for like NuGet key or something, like that's where I
Okay.
published to
Yeah.
your local feed.
Yeah.
That just how does the parameterization thing work?
Yeah, how does the parameterization of things like NuGet work here? Well, so the NuGet example, here it's really just using the predefined sort of constants I have at the top of the file. So the operation NuGet, in Fate, very often there's this pattern where it gives you default record, NuGet params, and you can clone it and set the things you want to specify, return a new NuGet params. And here I'm filling a couple of properties using what I defined at the beginning. So at the beginning, I have constants for the things that I want to put in here. If you were doing like your own specific build script, you can really just put it all in here directly. I had the constants at the beginning because it's copied from the template where you should really be able just to change the things at the top of the file. Yeah, to be honest, I haven't used this has-built param and get-built param or default very much. We can probably find the documentation for this on the Fate website. I suppose you can specify NuGet key parameter to the build script, and then it will automatically publish the package. String to join.
Yeah. I know string concat from FsCheck module.
That must have been written by someone else. I don't know what string join is. Cool. So I think that's the core of the build script here. And so building is one thing. The other thing I get in the template is this F# formatting documentation. And that's a tool that basically lets you write two forms of documentation for your projects. One is that you can write tutorials just by writing a script file that demonstrates how to use your library. The other thing is it also lets you write or take these sort of XML comments and turn that into a reference page. So if I want to use the script file, and I'm really going to just show that in Visual Studio. So if I wanted to add documentation to this, it's already here in the docs, folder, and there's index, which has a couple of things. That's not really the interesting one, or I'll show that later. But it comes with this tutorial.fsx, which is where you can write a tutorial for explaining how to use the library. Now again, I can run all of it in F# Interactive immediately when writing the tutorial. But then, let me just copy this bit from here. So if I want to document this, in this script file, I can use this like double star command. And what the tool does is that whenever you use double star, it will treat it as a documentation content. And I can write my comments here. So to use email validator, you first need to reference the DLL library. And in here, you can use the usual markdown formatting things. So backtick means treat this as code, or treat it as code. Then this demonstrates how I reference it. And now we can double star will make it bold. So we're really excited about the documentation, I think. And this shows how we can run it, and so on. So when I'm writing the documentation, in the tools, there's this generate. And what this does is that this uses the F# formatting to build the documentation. I can just run it all from F# Interactive. And again, this is a thing that you don't really have to change, but I'll explain what it does in a moment. So what happened is that it generated this output folder with my documentation. And tutorial is the bit that we've been writing. And look at that, here's so when I said, now we can create some validators, it's formatted here. So it actually takes what I was writing there. I'm not sort of cheating here. And let me show you one more thing. Woohoo, tooltips. So what it does is that it uses the F# compiler service to look at all the identifiers and generate JavaScript tooltips. So you can really sort of read it as when you're reading F# code. What is it? Yeah.
So question about code snippets. So are F# and C# only languages supported? So if I want to do code snippet like in SQL or Python?
Yes, let's see. I don't think I have SQL. So the question was, what kind of languages can I put in here? So it takes all these sort of snippets that are normal F# code, and these are turned into snippets. If you want to put some other language snippet, then you can use the usual markdown thing, and this will turn test into a code snippet. And I think if I just put it in like this, then let's see what happens. Test, now it treats it as code. You can put annotation here and say lang equals SQL. I don't think this is going to work. I don't think the formatting library we're using there supports SQL. Well, how would I know anyway if I'm going to say something?
No, it doesn't.
But it definitely, I think I might have to close this. Otherwise it can't regenerate it. It's printing lots of stuff. I'll explain what's happening. Hey, look at that. It does support SQL. I didn't even know. I know it supports like HTML and XML, but yeah. Magic. Wow, I'm impressed. Yes, so that was the formatting. The other thing that this does is that it generates. Well, let me first show you the index page. So I have two FSX files here. One is my tutorial, the other is index. And the index is just sort of the index page where in the markdown, you can actually put in HTML inline as well if you want to do some more fancy formatting. This is showing how you can do lists and links in markdown. There's a couple of other things, and this is used to generate the index page. So here, I think it lost. Doesn't work. Yeah, this is ugly. It's not loading the CSS file for some reason, but probably some wrong URL somewhere. The other thing that it does is that it also generates this API reference. So here we have all our things and all our sorts of things from the library. None of these are nicely documented. So we'll have to change that. And that the API reference, that's generated from the XML comments in here. Now, I didn't have any XML comments here. In F-sharp, you don't really have to write XML, so it's more pleasant than that. I requirement, so interface that represents requirement. If you just put in triple slash, that will treat it as a summary. That's it. Now I'm going to cheat because I don't want to waste too much of your time. And I think I have a comment for this one. I don't really have comments for these. So let me just put in something. Length greater than 8. Here, so not only you don't have to write XML, but we actually allow you to write Markdown. There should be a digit, uppercase thing. Yeah, my documentation is getting sloppy. That's lots of things.
Still up to date?
Yeah. Anyway. So this is something that's not really going to work nicely in the Visual Studio at the moment. If I put in like markdown comment, it really just shows it in line. That's one feature that someone needs to implement on the F-sharp formatting library. So if you're thinking about contributing to F-sharp open source projects, this is one fun thing to do. It's really just a matter of taking one discriminated union, which has the markdown, and producing the XML file that Visual Studio expects. If someone could do that, that would be nice, because then you could see it more reasonably formatted here. But if I now regenerate, so before I generate documentation, I actually have to rebuild this, because the comments, it takes it from the XML file. But now I can rerun this, and it updates all the documentations. tutorial, this works. And the API reference, woohoo! Now we've got all the nice comments, and this was the module description where I used Markdown. It actually formats this as nice Markdown. If I look at the requirements, like this one, this is where I use the backtick formatting to say this is some code. So it's sort of pretty developer friendly, I think, which is what I want when I have to write documentation. And this is something that pretty much quite a few of the standard F# open source libraries on GitHub use. We've been using this for the D library that we created with Blue Mountain Capital. So this has pretty much follows the same style, really. This one has one additional thing, which is that it actually evaluates the snippets and shows the output. That's one thing that's not integrated in the template yet. And another nice thing in here is in the API reference, when I look at some modules, like we've got this series module that contains operations on time series. All of these functions have name, the documentation, there's the type as well, and they have this little nice icon. So if I think that last key is poorly documented, I don't really understand what it does, I can click here, and it jumps to the GitHub source code for it. So what just happened is that when it generates the documentation, it actually finds the location of the function definition in your source code, and because I gave it GitHub location for my project, it can generate link that leads directly to that location, to that function on GitHub. So yeah, this is pretty nice. All right, so that was creating a nice documentation. And fake, I actually already talked about fake, so I was reversing the order of my talk here, which luckily worked fine. The last thing I should have done here, so let me just open my final version of the library, and let me just change something in the documentation. So I'm going to add this is probably not a useful addition to the documentation, but I just want to show what happens if I go back here and go back to final. Previously, I was just running build. The other option is I can say build release, and this does the build, and that's what you would do when you want to build a new version. So it runs the tests, that's happening here, but then it also runs the documentation generator. So now it's generating all the documentation. Now it actually cloned the GH pages branch from GitHub. So on GitHub, you have this option to host sort of documentation for your packages or web page for your packages. It clones that, copies the new documentation there, and now if I put in my GitHub password, it will commit the changes and put it into GitHub. So if I can remember where this actually is, it's in final. Where is this? So if I go, there it is, I think. sample tutorial. Now it's not blue. Why is it not blue? I didn't put in the language. Yeah. If I fix it and run my build release again, then hopefully that will get fixed. It might take some time for GitHub to actually update it. So maybe this isn't going to be as impressive demo if GitHub decides that I'll have to wait a few minutes before it updates the page. But I think this is the interesting thing here is when you're sort of maintaining an open source project, you really don't want to spend more time than typing build space release enter when someone sends you a pull request. Hey, it's blue. So it actually updated the documentation, and this is live on GitHub on the internet. It's not looking at my local machine. You can go there with your iPhone and read the documentation. It works when it's on a small screen as well. The other thing I haven't really mentioned is if you look at many of the open source projects, like FsCheck formatting here, there's one more thing I haven't talked about, and that's integration, that's continuous integration. So for quite a few of them, we are using the Travis CI server, and they'll make it possible to use it for free for open source projects. And this is sort of, there's a hook for GitHub that every time you push into GitHub, it will trigger the build. And here, yeah, I can look at the build history. So there's a couple of failures, but that's because I'm just not excluding a branch that really shouldn't be building.
Is it same as a PPBear? Is it same idea?
Sorry?
Is it same as a PPBear?
Yes. So the question is if that's the same thing as the appware, or how do you pronounce it? Yeah, that's pretty much the same. There's quite a few different continuous integration servers that work nicely with GitHub. Travis is just one of them. The nice thing here, this is actually running the build on some sort of Mac machine, so it's using Mono. Yeah, you can see it from all the funny stuff it prints. Whoa, proper log file here, but it does run the build and the tests on Mono. So most of the open source FsCheck open source projects have this set up and actually run the tests on Mono. So pretty much everything in the FsCheck world is nicely cross-platform.
So they allow to build for iOS?
Sorry?
You can build for iOS?
So the question is if I can build for iOS. I don't really know.
Okay.
Yeah. I think you can tweak this in quite a lot of ways. So
I mean, you need Mac hardware, right, to build?
Yeah, I think this is running on Mac hardware. I'm not entirely sure.
You think it's Mono?
Yes, this is running using Mono.
So if you use Mono, you can use the Mac system. If it's Mono,
Yeah, but you need Mac machine to build it, right? So you can do it.
I don't really know what these guys are doing there behind the scenes. If they have just a lot of Macs that they give to people for free, or whatever. This has one nice other feature which I couldn't show, and that's when someone sends you a pull request on GitHub, it runs the automated build on their code. So if someone sends you a pull request that breaks your project, you don't really have to test it. You can just tell them, look, it failed, fix it. So it makes the open source project management much nicer. So I think to wrap up, I hope that the talk wasn't as boring as I was promising. Because even the boring things like unit testing, building, writing documentation, they actually can be quite fun if you use the right tool for them. There's a lot of interesting libraries in the F# world, and quite a few of them, they actually work with C# as well. And it's also a risk-free way of actually starting with F#. So I've heard somewhere that 75% of the statistics are made on the spot. This is one of them. But my idea is that when you're doing some software, production code is really just one part of it. There's a lot of other things that you have to do. And starting with F# there might really be a nice, easy way to have some F# fun on the side, even when you're working outside of F# world. Okay, thanks for coming, and I think we can answer some questions now.
How did you create the project? Did you have to go manually change the?
Sorry?
How did you change all the project names? Did you have to do it manually, or did you have any?
How did I change the project names? I have done it manually. There's a pull request there that on the project scaffold that adds a script to do it for you. So there's just sort of, yeah, I think in the version that's going to be there pretty soon, there's going to be just some command you can run to rename everything. Any other questions?
So what's the best example of a project currently? Zidle?
What's the best project on the internet that uses all of it? I think F# data is probably the most.
F# data is so complex.
F# data is kind of complex, yeah. Zidle is easier and does a lot, does pretty much all of the things I was showing. But really just the project scaffold has everything in the sort of simplest form. So
is there any scaffolding for type providers?
Is there any scaffolding for type providers? Yes, there's a warning on that scaffold page that says don't use it for type providers. There's only one thing that doesn't work with type providers. If you're working on type providers, you can't have the tests in the same solution as your source code, because if I open the test, it will load the type provider and that will block it. That will load the DLL and you won't be able to rebuild it. So
yeah, documentation, same problem, right?
and the same, yes.
So
there's the same problem with
does it
documents.
use right now kind of F# compiler services? I mean, can you do shadow copying there? To lock?
I think F#. So there's an upcoming change in F# Interactive that will do shadow copying, but you kind of still want to. No, maybe that will work. Yeah.
Because it's kind of annoying. Once you open up to edit documentation, you have to close and all.
Yeah.
So the Visual Studio.
Really, the only thing you would have to do to use this with type provider is to remove the source code, or I guess remove this part and this. Well, take out the text and the docs and move it to a separate solution. So there's not that much you would have to do. Just sort of copy and paste the solution and delete one part of the things from one solution, the other part from the other solution.
Oh, that's actually fine, but like the documentation, you probably want to keep it in the same solution, right?
Yeah, so I think in F# data, which has type providers, we have documentation in the same place as the tests, and the code is there. But computers these days can usually handle two Visual Studios open in parallel. So, well, some of them sometimes, unless you open too many things in your Visual Studio.
If we wanted to do monkey, what's your recommendation for?
Oh, so I think this is off record, but there's a library for F# which follows the good F# tradition of prefixing names with F. For .NET, there's a mock. For F# there's a accordingly named library. If you Google it, it's FOQ. I'm not going to pronounce it. It's Phil Frelford's library. I'm not responsible for that. But even mock will actually work really nicely with F#. So if you're used to mock, then you can do that. If you want to be F# specific, you can use FOP. Yeah.
What about testing F# code GPU and the GPU? Do you have any libraries?
Oh, so if I wanted to do something on GPU, then I think that's well beyond the scope of the answer. I think we'll have to talk about this in the talk. But there's a library for translating F# code to GPU called quant_alia Cubase, and I don't know what all the things they do, but it seems to be pretty advanced. All right. Well, thanks again for coming. And